In this example, we're going to convert 2.3 times 10 to the 4 hectometers per second squared to nanometers per picosecond squared. Now, the first thing some of you might be thinking is, where would you ever possibly see these types of units? Well, we have length per unit of time squared. So those are actually the units for acceleration. So if you have a body that is changing its velocity, it's accelerating. And these are the units that that acceleration would hold. Now, typically we have meters per second squared or kilometers per hour squared, but these are perfectly valid units for an acceleration. Now, to make this conversion, the first thing we need to realize is that we actually have to make two conversions. We have to go hectometers to nanoseconds, or hectometers to nanometers, and seconds squared to picoseconds squared. So what I do is I say, okay, hectometers to nanometers, and then we have to go seconds squared to picoseconds squared. So we need to find both conversion factors. Hecto corresponds to 10 to the power of 2. Nano corresponds to 10 to the power of negative 9. So 2 take away negative 9 is going to equal 11. So I know that 1 hectometer is equal to 10 to the 11 nanometers. And I will put a box around that conversion factor. The next thing I need to do is go from second squared to picosecond squared. So there's no prefix attached to seconds, so we know that's unity, and that corresponds to 10 to the power of 0. Pico corresponds to 10 to the negative 12. So we're going to go 0 take away negative 12, which is just equal to 12. So I can say that 1 second squared is equal to 10 to the 12, or sorry, 1 second is equal to 10 to the 12 picoseconds. But I'm not looking to go from seconds to picoseconds. I want seconds squared to picoseconds squared. So I need to square both sides of my conversion factor. So I get 1 second squared is equal to 10 to the power of 12 picoseconds squared. So 1 to the power of 2 is just 1. So I get 1 second squared is equal to 10 to the power of 12 to the power of 2, so it's going to be 12 times 2, which gives me 24. So 10 to the power of 24 picoseconds squared. And again, I'll put a box around that. Now that I have both my conversion factors, I can go on to multiplication. So just like I did in the other questions, I'm going to start out by writing down the quantity that I was given. So this becomes 2.3 times 10 to the 4 hectometers per second squared. Now, since I have two conversion factors, I technically need to do two multiplications. So I'm going to draw two sets of brackets. And I usually deal with my units in my numerator first. So I have hectometers on top. I want those to cancel out to become nanometers. So I put hectometers on the bottom. If hectometers are on the bottom, that means nanometers must be on top. And using this conversion factor, I said 1 hectometer is equal to 10 to the 11 nanometers. And if I look at this, I can quickly see that my hectometers will cancel out with my hectometers. Now, when I go from second squared to picosecond squared, in this case, I note that second squared is on the bottom. So in order to get second squared to cancel out, leaving me with picosecond squared, I need to put the second squared on the top over here. So second squared on top, picoseconds squared on the bottom. And I said that 1 second squared is equal to 10 to the 24 picoseconds squared. And now my second squared will cancel out with my second squared. So when I'm done, I'm left with nanometers over picosecond squared. The next thing to do is to make sure that I have the right power of 10 with my conversion. So this is going to equal to 2.3 times 10 to the power of 4. And then it's being multiplied by 10 to the power of 11, so that's plus 11. And then it's being divided by 10 to the power of 24, so it's going to be minus 24. And my units are going to be nanometers over picoseconds squared. So this leaves me with 2.3 times 10 to the power of 4 plus 11 is going to give me 15. And then I need to minus 24. So again, if you're in a testing situation, you want to be careful when you're doing these types of calculations because lots of times students make mistakes. So 4 plus 11, that's easy. That's 15 minus 24. So what I would do first is I would go 15 minus 10, which is going to give me 5. If I minus 10 again, that's going to give me negative 5. And then if I minus 4, that gives me negative 9. So this is going to be 10 to the power of negative 9 nanometers over picoseconds squared. Now I know lots of students, especially when they've done these types of conversions before or have made these conversions before, perhaps using another method, they're hesitant to try to do it this way. But to work through a problem like this and get a correct answer using any other method would be very, very difficult and time consuming. Using this dimensional analysis will make answering questions like this very doable, and you will have to answer questions similar to this on your first test.